When the James Webb Space Telescope first pointed its infrared eye at Neptune, few guessed at the revelations that were to come. Launched with high aims of looking into the dawn of cosmic time and exploring the mysteries of ancient galaxies, Webb was conceived to push the limits of human knowledge. But in a turn nobody expected, the telescope pointed its eye back towards our own cosmic backyard. And what it saw about Neptune is reauthoring the history of the solar system itself. Neptune, previously shooed away as a remote chilly ice giant circling quietly at the periphery of our Sun's realm, has unexpectedly become a mystery planet. Historically, this eighth planet from the Sun had been viewed through a narrow prism, a huge cold world illuminated by methane-rich blue light veiled in cloud-wreathed winds and containing a dense core hidden beneath layer after layer of stagnant gases. A planetary enigma perhaps, but one that was believed to be well explicated in theory. That notion has now been utterly destroyed. The first pictures provided by Webb's near-infrared camera NAM were nothing short of stunning. Far from the blurry blue invisible light telescopes, Neptune presented itself in stunning detail. Heat patterns, cloud cover, and obscure dynamics appeared, stripping away the reductionist picture we had once possessed. What was revealed instead was a churning, turbulent world, a world brimming with movement, complexity, and unexplainable action. One of the most shocking finds was in the upper atmosphere of Neptune. Long assumed to be cold and relatively inert because of its tremendous distance from the Sun, the area instead showed extreme thermal irregularities. Large regions were reading warmer than they ought to have been by many degrees Kelvin, implying local sources of heat. Where was this warmth, though? The Sun's power at that distance is negligible, and current models couldn't account for the anomalies. Scientists then started guessing about internal processes previously underappreciated or misunderstood. Perhaps heat release from far inside the planet or interactions between Neptune's upper atmosphere and its magnetic field that produced friction and heat. Methane also turned into an unwelcome complication. This substance, which was responsible for absorbing red light and rebounding blue, was responsible for Neptune's distinctive hue. But the spectroscopic information from Webb indicated that methane wasn't uniformly spread throughout the planet. There were rich concentrations in some places, while others were strangely depleted. This created disconcerting questions concerning Neptune's atmospheric processes. How does an irregular distribution occur in a planet allegedly ruled by smooth, uniform weather patterns? What are the driving forces concentrating or diluting this gas in various regions? The solutions elude us, but the implications are profound, throwing into question our very models of planetary weather, chemistry, and origin. And that was only the beginning. Webb's instruments enabled scientists to probe deeper into Neptune's interior than ever before. The crossing from Neptune's outer atmosphere into its interior, previously assumed to be a straightforward gradient from gas to ice to core, was found to be much more turbulent. Webb picked up on oscillating areas of pressure and density, suggesting turbulence in the planet's deeper depths. Some of these regions could have pockets of superionic ice, a strange form of water in which hydrogen ions are free to travel through a lattice of oxygen atoms, imparting it metallic properties. Superionic ice has long been speculated to exist in the interiors of ice giants, but Webb's observations indicate that it might not be confined neatly. Rather, it might be distributed throughout Neptune's interior in turbulent, unstable areas, actively shaping magnetic and thermal activity on the planet. Neptune's own magnetic field, already a strange phenomenon among planets, grew increasingly perplexing under Webb's analysis. Unlike Earth's fairly aligned magnetic poles, Neptune's field is tilted at a surreal angle nearly 47 degrees from its axis of rotation and shifted well off the center of the planet. But now Webb has found that this field isn't stable in the first place. It varies over time, displaying evidence of abrupt peaks, dips, and local magnetic vacuums. Such temporal variations imply a chaotically unstable dynamo process operating within Neptune, one that's counter to present theories of magnetic field origin in planetary bodies. Might the scattered superionic ice be having a pivotal role here? Or is some other yet unidentified process behind this magnetic craziness? But possibly the most fascinating implications are not from Neptune itself, but from its largest moon, Triton. Triton has always been a cosmic oddball, an icy moon that orbits in the opposite direction, retrograde, probably a captured Kuiper belt object, and with surface features associated with ongoing cryovolcanism. When Webb pointed its instruments at Triton, it registered spectral traces of chemical molecules that don't have anything like them in the outer solar system. These may be hydrocarbons, ammonia, or perhaps something entirely foreign. Some scientists now theorize that Triton might not be a passive satellite at all, but an active participant in a bigger chemical exchange with Neptune, maybe bonded by magnetic field lines or subatomic particle streams. Might the two worlds be engaged in a dynamic interactive relationship, a binary system really, rather than a standard planet-moon system? And then there are Neptune's rings, a mere distraction, a faint smudge even to great telescopes. Webb eliminated that. For the first time in decades, Neptune's rings were filmed in high definition, not only exposing their structure, but their secrets. Gaps, arcs, and clumps showed up where none should have been. These structures contradicted the simple gravitational models that had once described them. Although small shepherd moons have been employed to explain some of these structures, Webb's acuity indicates that even that description may not suffice. Some anomalies suggest transient effects, short flashing occurrences created by interaction with charged particles or as yet unknown small bodies following near-circular paths close to the planet. Others suggest forces we just can't fathom. As these discoveries accumulated, the unavoidable conclusion came into view: Neptune is not the cold fossil we imagined. It is not a sleeping gas ball passively circling the sun's outer limits. It is a dynamic planet of unseen heat, of chemical richness, of magnetic turmoil. It is, in short, a puzzled planet that resists categorization. And that raises an even bigger question: if we've misrepresented Neptune so deeply, what does that portend for the several hundred exoplanets we've termed Neptune-like? These remote bodies, many of which orbit stars hundreds of light-years away, have been characterized based on inferences derived from our own planetary system. If Neptune itself was inaccurately typified, those projections are likely to be seriously erroneous. The atmospheric fingerprints that we read as indicators of stability could instead represent signals of surreptitious volatility. The magnetic or thermal measurements we take for granted may actually indicate exotic phenomena we have not yet started to understand. Webb's observations force a re-evaluation not just of Neptune but of planetary science as a whole. They suggest that our categories, gas giant, ice giant, terrestrial, may be too simple to contain the diversity of real planetary behavior. They hint that the processes shaping planets are far more variable and far more violent than previously imagined. This includes theories about planetary migration. Some astronomers have long hypothesized that Neptune didn't condense into its current position. Rather, it could have started much closer to the Sun and was subsequently hurled outward during the solar system's violent adolescence, buffeted by gravitational collisions with Jupiter, Saturn, or even a hypothetical fifth giant planet that might have once existed. Webb's observations now lend support to this hypothesis. The discrepancies in Neptune's interior, the unusual energy emanations, the irregularities in its rings and moons, these might all be remnants of a tumultuous history, scarring from a planetary odyssey that reached its terminus on the solar system's periphery. One enigma that remains puzzling for scientists is Neptune's internal heat. Though it lies beyond Uranus in distance from the Sun, Neptune radiates almost twice as much internal heat. No one has been able to explain it for decades. With Webb's new data indicating unexplained energy peaks and oscillating thermal signatures, the question grows more pressing. Could radioactive decay deep in the planet be generating more heat than thought? Is there tidal heating from Triton or another moon? Or is some other process occurring, some form of exotic fusion-like reaction or chemical reactions we can't yet account for? These are no longer theoretical questions. They are observation-driven puzzles posed by direct observation, and they're already changing the way scientists approach planetary physics. Neptune, a former planetary footnote, is now at the center of a scientific revolution. And the science world recognizes old paradigms are being overthrown. Research papers are being rewritten. Whole conferences are now being set up around reinterpretation of what Webb has taught us. Shock waves from these Neptune findings are resonating throughout the fields of planetary science, astrophysics, and even exoplanetary science. It's a reminder of the humbling power of science, that even the most long-standing theories can fall apart in the face of improved information. The James Webb Space Telescope was designed to reveal the universe at its dawn. And it has. But its most revolutionary discoveries thus far have come from the neighborhood next door. Neptune, a world that few humans ever gave much thought to, few scientists ever investigated in detail, has become the focus of a cosmic enigma that could take decades to solve. This is more than the tale of an ill-understood world. It's a tale about the boundaries of what we know and the need for curiosity. It's a tale of how even the most sophisticated scientific instruments can catch us off guard, teaching us that the universe is always more complicated than we think. Neptune is no longer a serene blue world on the periphery of the solar system. It is a churning, lighted, agitated anomaly, a reminder that in the great theater of space, the most bizarre yarns prove to be the most proximate. If you like this dive into the mystery of Neptune, be sure to like this video and subscribe to our channel for even more cosmic surprises. Leave us a comment below. What do you believe is behind Neptune's strange behavior? Is this a one-time anomaly? Or are we about to find out that our whole concept of planetary science has been mistaken this whole time? Until then, keep looking up. The universe has its work cut out for it. If you want, I can also smooth the grammar, fix typos like web, and make the flow more polished while keeping all your original details. That would make it read like a finished article. Would you like me to do that next?